Chalo. Now we'll start with a new topic, viscosity. Viscosity इसके बारे में फिर learning. मालूम है ना viscosity क्या है बोल के? What is viscosity? Anybody? Anything you know? Viscosity.
Sir, forgot, sir.
Like a water को, if we will stir, we can stir very easily, right? But same honey दिया, if I given honey to you, stir करो बोलते it is very difficult. So it is offering some resistance, right? Resistance property को we call as viscosity. Resistance property को honey को घुमाने के लिए बहुत तेजी से घुमाना, मतलब very difficult to rotate, right? So some resistance is offering. That property को we call as viscosity. Okay. और देखिए, first we learn about the viscous force learn करेंगे. Liquid में viscous force learn करेंगे. Okay. एक liquid layer लिया है, where it starts moving. The liquid layer starts flowing. Okay. So what is viscous force? When a fluid, liquid or gas flows, different layer moves with different velocities. एक layer will move with different velocities. The bottom layer, which is touching the ground, will move with a less speed, speed. Sometimes we can treat as zero also. As we go above the surface of the earth, the liquid will move very faster. Okay. तो देखो ऐसा होगा. Solid surface के साथ जो भी join हुआ, उसका speed is less. ऊपर जाने समय speed थोड़ा आगे निकलते जाएगा. Layer. एक waters are flowing. That means layer is flowing, right? Bottom layer which is touching is almost zero. We can take very minimum velocity से move होगा. And आगे का ऊपर वाला will move with faster speed. Okay, because here friction ज़्यादा है, right? Friction between the solid surface and liquid surface का friction is there, right? उसके वजह से धीरे जाएगा. The layer in contact with the solid surface moves slowest, while the top layer moves fastest. Top layer moves fastest. Due to this difference in velocities, velocity difference के वजह से, a tangential force acts between the layers of the fluid. एक force act होगा because of difference in velocities. एक force act होगा, and that is called viscous force. This one as viscous force. Like internal friction को we call as viscous force. Okay, friction force को indirectly we call as viscous force. देखो. ना लिखो. Physical maths बोल के बोलेगा. क्या पढ़ेगा अभी? पढ़ो. Time आने के पढ़ो. Time देना. 24 hours is there. I think tomorrow holiday also, right? For you?
So no, sir. They gave us school.
Oh no. ऊपर यार सबको holidays दे दिया. And this Monday exam again, coming Monday?
Yeah.
Which one? Topic?
Sir, whole from April whatever.
Oh, complete syllabus, huh?
Kinematics, sorry.
Okay. From kinematics से ये भी ये chapter भी है?
No, sir. We have until fluids, entire fluids, entire RBD, entire CM, all that.
Okay, sure. So viscous force will be coming into picture layer to layer के बीच में. The formula वगैरह will learn. Then okay. चलो. No. अब देखो एक layer लिया है and top layer दिया है. Okay, layer to layer I'm talking about. Bottom का layer and bottom का layer में velocity मान लो v velocity से जा रहा है. And उसका above वाला layer को v plus dv small velocity ज्यादा रहेगा ना. ऊपर वाला layer, bottom layer is less, top layer is more. Okay. Now क्या है इसका distance from this ground से मान लो ये y है and from this ground से मान लो y plus dv dy distance. Okay. Then there is a viscous force acting because of difference in the velocity. Viscous force is acting. Fv, viscous force is acting, and that viscous force is proportional to mano आप पढ़ो, क्या पढ़ रहे चले, फर्स्ट ऑफ ऑल टेस्ट पढ़ेगा, पढ़ो, बाद में टाइम रहेगा यार, इधर कॉन्सेंट्रेट नहीं करेगा उधर कॉन्सेंट्रेट करेगा, इधर इधर पढ़ने में क्या फायदा, यू रीड एंड देन कम, आप इस पे कॉन्सेंट्रेट करो वो नीचे देखते रहेगा, ठीक है, उस पे क्या टाइम है वो पढ़ो, 23 आवर्स इज देयर, अभी इसमें कॉन्सेंट्रेट करने से उसमें आएगा, देखो, द विस्कस फोर्स is proportional to area of contact, area पर depend होगा, and viscous force is also proportional to velocity gradient. Velocity gradient क्या है? Change in velocity by change in distance को we call as velocity gradient. Change in velocity by change in distance को velocity gradient बोलते हैं. ऑनलाइन करो, तब से मार्क्स कम होना शुरू कर दिया, जब पढ़ना शुरू किया क्लास में तब से मार्क्स कम हो रहे हैं सभी में, देखो इधर टेस्ट हो रहा है उधर भी टेस्ट में ऐसे कम आ रहा है. And when I remove proportionality, we get a constant that is minus eta a dv by dy. This is the formula for viscous force. Fv is equal to minus eta a dv by dy. Velocity gradient. कितना velocity change हो रहा है with respect to distance को, it's called velocity gradient बोलते हैं. Okay. And eta is called coefficient of viscosity. Coefficient of viscosity. Represents eta. Represents eta. So Fv is equal to minus eta a dv by dy. dv is nothing but change in velocity of the two layers by distance. dy is nothing but change in distance.
So is that dv by y?
Or dv by dy.
So v is volume or velocity?
Velocity. dv is the देखो v plus dv. देखो नीचे का velocity v है, ऊपर का velocity ज्यादा जाएगा ना, v plus dv, differentiation dv, change in velocity. तो विस्कस फोर्स का फॉर्मूला आ गया माइनस ईटा ए डीवी बाई डी बाई, माइनस मींस इनडायरेक्टली अपोजिट डायरेक्शन में बोलने के लिए दिया है, विच डायरेक्शन, अपोजिट डायरेक्शन माइनस लगाने की जरूरत नहीं, माइनस ईटा ए डीवी बाई डी बाई इज द एग्जैक्ट फॉर्मूला. एंड दिस कोएफिशिएंट ऑफ विस्कोसिटी इज नथिंग बट प्रॉपर्टी ऑफ द फ्लूइड ओनली. एक एक फ्लूइड का एक एक कोएफिशिएंट ऑफ विस्कोसिटी रहेगा, उसके वजह से फ्रिक्शन फोर्स इज मोर, लाइक हनी का वैल्यू कोएफिशिएंट ऑफ विस्कोसिटी इज मोर देन वाटर का, दैट्स व्हाई viscous force will be honey का ज्यादा रहेगा compared to sun. But
going to draw the diagram.
Yeah, teacher.
No, sir, do I need to draw the diagram?
बाद में diagram ड्रॉ करो ऐसा. हाँ, this diagram निकलेंगे. हाँ, yeah, diagram ड्रॉ करो.
This is on the previous one. Previous one diagram I didn't draw.
No problem. But understand, bottom में speed is less because friction is more. And as we go above, the speed थोड़ा layer to layer वाला ज्यादा रहेगा. That's why I took here V, and this is V plus dV. तो speed ज्यादा है. Okay. And now two layers के बीच में area of contact को A बोलते हैं. इसका depends on the area of contact. And as का formula आ गया. Tell me. Fv is equal to minus eta A dV by dy is the formula. Change in velocity by change in distance. Okay.
Yeah.
देखो negative signs show that viscous force acts in the direction opposite direction to that of motion of the liquid. And दूसरा, we talk about coefficient of viscosity. So what is coefficient of viscosity? ये define कर सकते हैं? दूसरा बोल सकते हैं? Coefficient of viscosity means क्या है? In the formula से निकल देखो. F is equal to eta a dv by dy, right? So eta is equal to F by a into dv by dy. अगर 1 meter square का area लूँगा, velocity gradient is also 1. Then the coefficient of viscosity is exactly equal to viscous force. तो कितना viscous force है? That is only coefficient of viscosity. So defined as viscous force acting per unit area when the velocity gradient between the layer fluids are unity. When the coefficient velocity gradient between two layers of fluid is unity, then this is 1, this is 1. Then viscous force is exactly equal to coefficient of viscosity, theta. And units बोल सकते हो इसका famous units theta. नहीं है theta का कौन पढ़ना?
So won't it be pressures units?
SI unit 7. नॉट प्रेशर यूनिट्स. ओके देखो, सो इसका यूनिट्स ले लो. डायमेंशंस तो मालूम है. एक वेरी फेमस एग्जाम पूछा है डायमेंशंस आल्सो. एम एल इनवर्स टी इनवर्स आएगा डायमेंशंस. एंड यूनिट्स देखो, ऐसे यूनिट्स इज न्यूटन सेकंड पर मीटर स्क्वायर और पास्कल सेकंड. Units are Newton second per meter square. Pascal second is the SI units of the coefficient of viscosity का. Coefficient of viscosity का SI units. But sometimes CGS units are famous. CGS units में क्या बोलते हैं? Poise बोलते हैं. CGS में Poise बोलते हैं. Okay. And higher units of the CGS units में decapoise बोलते हैं. Decapoise. And what is the relation? 1 decapoise is nothing but 10 poise. And that is equal to Pascal second only. देखो Pascal second. That's why sometimes they will write eta is nothing but 1 decapoise. Decapoise. But this is not SI unit. 1 decapoise is not SI units. Pascal second is SI units and Newton second per meter square. But value wise में decapoise and Pascal second is same बोल के they will mention. So these are CGS units. These are SI units.
So 1 Pascal per second is 1 decapoise.
1 decapoise. And 1 decapoise, deca is 10, right? 10 poise. So this is it. So a confusion में तो people will get confused. SI units of eta means they tell 1 decapoise नहीं. Pascal second को decapoise बोल के बोला. That's why they will mention this too. Same बोल. No problem. Poise में दिया तो आपको क्वेश्चंस पूरा मतलब वैल्यू शुड बी कन्वर्टेड इनटू सीजीएस यूनिट. मतलब आपको ऐसा यूनिट से एक यूनिट में कन्वर्ट करना पड़ेगा ऑब्वियस.
Yeah, so done. Is it Pascal per second?
Pascal second.
Was multiplied.
Dash second. Pascal second.
Yeah, done.
Sure. Okay.
So wait a second, forgot to write the formula. Yeah, so done.
इसका क्वेश्चंस करने वाला जेईई में क्वेश्चंस करने वाला पूरा. इफेक्ट ऑफ टेम्परेचर ऑन विस्कोसिटी क्या होगा, लिक्विड्स में क्या होगा एंड इसका क्या होगा. देखो the viscosity of liquid decreases with an increase in temperature. As the temperature increases, viscosity of the liquid decreases. मतलब because of intermolecular forces of attraction क्या होगा, decrease हो जाएगा. That's why उसका as temperature increases, the viscous layer will be decreasing. मतलब viscosity is decreasing. मतलब actually they will write like this. Theta is inversely proportional to 1 by root t. T is the temperature. ऐसा decrease होगा in liquids में. But gases में उल्टा होगा. Viscosity of the gases increases with an increase in temperature, and in this way, eta is proportional to. So a direct relation है, a inverse relation. So viscous force का फॉर्मूला है ना minus eta a dv by dy. dv is change in velocity, dy is a change in distance. इनिशियल डिस्टेंस वैल्यू फाइनल ऊपर लेयर का डिस्टेंस वैल्यू सेपरेट करेगा जैसे. तो विस्कस लेयर्स इजी है. विस्कोसिटी का कांसेप्ट सिंपल, एक ही फॉर्मूला है. Elasticity chapter is so easy to change, just formula based. Okay. Numericals correct. Okay, ठीक है करो. Without seeing one. A plate of area 100 centimeter square is placed on the upper surface of the castor oil. एक upper surface है, oil है. Okay. इसका thickness है 2 millimeter. Thickness. Taking the coefficient of viscosity, देखो 15.5 poise. CGS units, right? ये भी CGS पे है ना, ये भी CGS पे कन्वर्ट करना पड़ेगा. All should be in CGS units. Poise बोलेंगे, you can all are CGS units. Calculate the horizontal velocity necessary to move the plate with a constant velocity. मैं कितना force से लगाऊं so that it moves with a constant velocity 3 centimeters per second. कितना constant velocity है? मतलब to move with the constant velocity कौन सा force act होगा मैं अप्लाई करने समय कितना फोर्स कौन सा एक्ट होगा विस्कस फोर्स एक्टिंग मतलब विस्कस फोर्स फाइंड करो उसका ऑपोजिट डायरेक्शन में फोर्स लगाओ इक्वल एंड ऑपोजिट में देन ओनली इट विल मूव विद कांस्टेंट वेलोसिटी आई यूज करो एंड बॉटम में यू कैन ट्रीट द वेलोसिटी ऑफ द प्लेट इज 0 मतलब वेलोसिटी ऑफ दिस लिक्विड सरफेस इज 0 ऊपर तो 3 मीटर्स पर सेकंड राइट now विस्कस फोर्स फाइंड करो पहले माइनस थीटा ए dv by dy डायरेक्शन लगा तो माइनस जरूरत नहीं बट डायरेक्शन लगा के ऑपोजिट डायरेक्शन में फोर्स अप्लाई करने का बोल के लिखो so it is equal to minus theta a dv by dy
Do we need to
So-
calculate?
thickness of the this one huh
Sir,
Tell me.
23,250.
23,250 yes
So I need to convert everything into millimeters or centimeters.
centimeter only this is serious units right centimeters is serious only millimeter nahi you are converted into centimeters so 1 centimeter is 10 millimeter right
So there's a 2 millimeters thick means diameter is 2 millimeters.
this is thickness oil का thickness मतलब dy is 2 millimeter मतलब 0.2 आएगा and dv is nothing but change velocity का कितना है 3 minus 0 is 3 कितना how much you got to know
Sir, dy will be what?
0.2 thickness dy is the
You
thickness
get 23,250 dynes, right?
huh
Yeah, so 27.
23,250 dynes.
yes हाँ next देखो विस्कस लेयर का व्हेन आई अप्लाइंग ए फोर्स विस्कस फोर्स एक्टिंग विस्कस फोर्स ओनली वी आर ट्राइंग टू फाइंड द सिस्टम ए मेटल ब्लॉक ऑफ एरिया 0.1 मीटर स्क्वायर ऐसा इसमें दिया एरिया दे गिवन है 0.10 मीटर स्क्वायर we connected to a mass 0.01 kg it's a connected mass connected string a pulley से block is connected via string that passes over massless and frictionless pulley shown figure a liquid with film of thickness a film है इधर a thickness मतलब dy is given as 0.3 millimeter मतलब कन्वर्ट करना पड़ेगा मीटर में okay is placed between the block and the table when released the block moves with a constant velocity of distance so block is moving with a constant velocity that is 0.085 meters per second because of what because of tension only it will move right the block is moving after release करने के लिए the quotient of viscosity of the liquid eta is how much eta is how much and downwards the mg the force factor mg force factor
So then what will be the force?
force is the weight on it
So force of mg only.
it is moving with some constant velocity means acceleration is how much nahi hai na
I got 283.
So what will be, so what will the force be?
what force
I
will be?
got 283.
Viscous force see it has to move with constant velocity right because of tension it is moving right constant velocity move होने के लिए आपको viscous force exactly equal and opposite लगाना पड़ेगा that means you try to find viscous force and then viscous force nothing but tension only exactly that much force may apply the block should apply so that it moves with a constant velocity so viscous force find correct directly and here T equal mg only and equate viscous force formula with mg
But what is 0.0?
So is it 283?
wrong ना हाई वैल्यू का कुछ ना विस्कस नहीं रहेगा
Sir, I'm getting approx 0.004 003 something.
3 years का चेंजिंग वेलोसिटी क्या होगा इधर 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 0 मान लो इधर v is this much changing velocity dv is nothing but 0.085 so eta a dv by dy is equal to mg so eta find karo everything is given area no
So I got
mg and a will
0.
cancel.
So I got 0.003.
0.003 yes correct Newton second per meter square
So mg and a will cancel. So all you have to find is n is equal to 1 by dv by dy.
So mg and
mg is see area is 0.1 only this is 0.01
Sir, even
mg
mg is
is
0.1.
yeah
But mg no.
And so dv by dy is 0.085 by 0.3 into 10 power minus 3.
so कैलकुलेट करने से आपको अप्रोक्सीमेटली सी ऑलवेज मैं कभी भी बोलता हूँ स्टैंडर्ड फॉर्मेट ऑलवेज टेल स्टैंडर्ड फॉर्मेट 0.001 इज द स्टैंडर्ड फॉर्मेट आपको साइंटिफिक मेथड मालूम है ना सो यूनिट्स एंड डायमेंशंस ऑफ सीक है ऑलवेज ये शुड बी यू आर राइट इन द फॉर्मेट ऑफ व्हाट समथिंग x into a into 10 power of m and the फॉर्मेट will take and a should be greater than equal to 1 less than 10 रहेगा so I said फॉर्मेट बोल 0.0 है क्या नहीं है ना so what is the format minimum 3 से स्टार्ट करने का राइट वो वाला वैल्यू में
3 into 10 to the power minus 3.
ऐसा बोलेगा दैट इज स्टैंडर्ड फॉर्मेट दैट सबका सेम आएगा नहीं तो 1% 0. बोलेगा 0.2 0. वो बार-बार एग्जाम में शुड कैंसिल चेक करना है ये कौन सा है सो स्टैंडर्ड फॉर्मेट में बोल रहे ऑलवेज ओके चलो नाउ नेक्स्ट वन इज स्टोक्स लॉ ये भी विस्कस फोर्स कैलकुलेट करने के लिए स्टोक्स लॉ इज गिवन ओके वेरी फेमस फार्मूला ओके ये फार्मूला कोई भी नहीं भूलेगा ये फार्मूला ओके सो रिगार्डिंग फोर्स or viscous force acting on a small spherical ball of radius r moving with uniform velocity through fluid of viscosity given by formula 6 pi eta rv so क्या होगा सपोज मान लो एक फ्लूइड में एनीथिंग फ्लूइड में एक स्फीयर इज देयर ऑफ रेडियस r it is moving with some velocity v then fluid में जाने समय it may be air also it may be water also fluid में जाने समय spherical ball only okay then there is a viscous force acting backwards that viscous force for this spherical body of radius r formula is given as 6 pi eta rv other shape का नहीं है पोर्शन में नहीं है only spherical body completely आपको अंदर fluid के अंदर है body completely fluid के अंदर है when it is moving then only viscous force will be acting 6 pi eta rv and you know the viscous force it depends on what are the things coefficient of viscosity radius and velocity of the body पर डिपेंड होता है ज्यादा स्पीड में जा रहे तो विस्कस फोर्स विल बी मोर सो विस्कस फोर्स इज 6 pi eta rv अच्छा है ना फॉर्मूला 6 pi eta rv so there no one will forget this one 6 pi eta rv
So this formula is used only if uniform velocity.
velocity constant velocity जा रहा है इन spherical body का जा रहा है then only you can use this one viscous force find करो बोले तो 6 pi e dot t and who is given Stokes is given that's the Stokes law will go
Yes, done.
done चलो next one terminal velocity last topic
So there,
हो गया था terminal velocity की जब मालूम होगा ना what terminal velocity means suppose any object is falling under the any fluid में object is falling suppose ऐसा गिरता जा रहा है so क्या होगा मालूम है एक certain time के बाद पहले it will actually start acceleration will be there right starting में acceleration will be there उसका velocity goes on increasing बाद में क्या होगा एक certain stage में आपको constant velocity से गिरेगा that constant velocity ko we call as terminal velocity. Why it fall with the constant velocity? Because any object under the fluid में buoyancy force will be acting and viscous force, Stokes Law से viscous force also acting. उसके वजह से आपको अब दोनों बैलेंस कर जाएगा, वेट के साथ बैलेंस करके it move with a constant velocity. That velocity is called terminal velocity. Okay. So when a body is dropped in a viscous fluid, एक fluid में गिर रहे हैं, it is first accelerated and then its acceleration becomes zero. That means it moves with a constant velocity called terminal velocity. Okay. VT से देखो इसका फॉर्मूला है 2/9 r square sigma minus rho by eta into g. बड़ा फॉर्मूला बट so many questions came JEE में तो बड़ा फॉर्मूला but is 2/9 r square sigma minus rho into g by eta is the formula for viscosity. तो इसका कहानी देखेंगे क्या क्या होगा. सिग्मा इज द ऑब्जेक्ट जो भी गिर रहा है ना उसका डेंसिटी को सिग्मा बोलते हैं एंड रो इज द डेंसिटी ऑफ द फ्लूइड. फ्लूइड में कौन सा गिर रहा है दैट इज द डेंसिटी. एक फ्लूइड में सपोज मानो एक स्फीयर इज फॉलिंग डाउन. ओके स्फीयर का डेंसिटी है वी कॉल्ड एज सिग्मा एंड रो इज द डेंसिटी ऑफ द फ्लूइड. Fluid density. Density of the object. Density of the object. And क्यों गिरेगा because एनर्जी से गिरेगा. तो एक कोई भी ऑब्जेक्ट होने दो, स्फीयर होने दो, ये होने दो, ये 2/9 r square into sigma minus rho into g by eta. And this is VT is nothing but terminal velocity. Terminal velocity. 2/9 r
So what
square.
is sigma?
Sigma is the density of the object. जो गिर रहा है ना, it can be raindrop होने दो, कुछ भी होने दो, इसका भी नहीं. And fluid is
sigma minus rho or sigma into rho.
sigma minus rho. Sigma minus.
Then what is rho?
Rho is the density of the fluid. Suppose एक ऑब्जेक्ट एक स्फीयर है, it is falling under the air. Air is nothing but the density of the fluid, rho, and the object जो भी है ना उसका density sigma. See, बुक्स में चेंज करेगा ये लोग sometimes रो लेगा, सिग्मा लेगा, फाइनली हमको आंसर चाहिए. सो एक फॉलो करो हो जाएगा. Don't get confused. इधर उधर करके मतलब ऑब्जेक्ट मतलब वो some books में they'll give रो density of the object is rho. So टेंशन मत ले लो और use only one. फॉर्मूला शीट के हिसाब से करो हो जाएगा. तो सिग्मा माइनस रो इनटू जी बाई ईटा एंड प्रोपोर्शनल टू आर स्क्वायर पर डिपेंड होगा. ओके इसका कहानी भी देखेंगे क्या होगा. कमिट चलो फोर्सेस एक्टिंग ऑन द स्फीयर्स आर दिस आर द फोर्सेस एक्टिंग ऑन. देखो सपोज इज आपको फ्लूइड है राइट. एयर इज अ फ्लूइड. एक रेन ड्रॉप होने दो और एनी स्फीयर होने दो. It is coming like this. This point. Initially, it is dropped. You tell me, initial drop करने समय drop है, इसका density is sigma, right? Initial drop means initial velocity is 0. इसके ऊपर what are the forces acting on it? Tell me. इसके ऊपर initially, if it is dropped under the fluid, which force is acting? Tell me. mg force acting. The sphere का mg mass है m. Sphere mg force acting. एंड वन मोर फोर्स कौन सा फोर्स है. व्हेन एवर फ्लूइड में अगर डिप किया तो क्या होगा. अपवर्ड फोर्स विल बी एक्टिंग. दैट इज कॉल्ड buoyancy. ओके सो buoyant force आई एम टेकिंग u इज अ buoyant force. लगा. ओके नाउ अभी वन मोर फोर्स आएगा. अभी नहीं आएगा. व्हाई बिकॉज़ आपको विस्कस फोर्स कौन सा फॉर्मूला क्या है. स्फीयर ऑफ रेडियस r फॉलिंग डाउन. क्या होगा विस्कस फोर्स 6 pi याद है 6 pi eta rv याद है. But initially velocity is 0, that's why viscous force is not there. Initially velocity is 0, that's why viscous force is not there. Okay. Now क्या होगा. It is moving with velocity v. And because of action due to gravity क्या होगा. It goes on increasing. The velocity starts increasing. Zoom 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 करके increase कर रहा है. increase when they start increasing, it has some velocity, right? When it's having velocity, this viscous force will be coming to picture. So viscous force will come into picture. So क्या होगा sphere? Now क्या होगा after certain time के बाद? Now नीचे तो mg act होगा, and ऊपर तो u act हो रहा है, buoyant force रहेगा, and there are one more force which is acting, which is viscous force. Because the velocity started, right? 6 pi eta RV. Since velocity started, viscous force also will be acting in the opposite direction. Okay. I said now देखो velocity increases, the viscous force also will increase. ये increase करके bottom वाले को balance कर देगा. And balance करने के बाद acceleration is 0. Now we start moving with a constant velocity. That is called terminal velocity. Terminal velocity. Okay. Now देखो formula मालूम है आपको? What is the formula for buoyant force? Tell me. Buoyant force and weight. Weight का formula. Weight का formula बोलो पहले. Weight का formula is mg रे. M is what? mg is what? What tell me? M का कैसे लिखेंगे? Density into volume, right? Volume is 4/3 pi r cube. इसका density is sigma, right? Sigma into g. This is a buoyant force, right? This is a buoyant force. This is a weight, right? This is a weight. And buoyant force formula is, याद है? Buoyant force U का formula, tell me. Vf into rho f into g, right? Vf is the volume of the solid immersed in the liquid, and density of the fluid, and g is the accelerated gravity. देखो, Vf into rho f into g. Rho f is the density of the fluid. कितना है density of the fluid? We took as rho. And v is the 4/3 pi r cube, because this is completely dipped inside it. Volume of the fluid, volume of the solid immersed in the liquid is nothing but volume of the solid only. 4/3 pi r cube rho into g. Right? Now, and viscous force का formula 6 pi a eta RV. Now tell me the equation. Tell me when the acceleration is 0, upward force into downward force. Now equation क्या होगा? Tell me.
Yeah.
U plus. देखो. Upward force into downward force. देखो इसका is equal to this. Right? We are equating this one. Very important आपको derivation में. See, people क्या करेगा? Only terminal velocity का formula बैठ कर लेगा. If they ask at least the values, just substitute and tell the answer. But आपको exam में क्या करेगा? They will tell that buoyant force is not there. Buoyant force is neglected. That time आपको क्या करने का? ये दोनों equal करना पड़ेगा. Buoyant force is not there बोल के बोलेगा question में. We neglect the buoyant force. That time क्या करेगा? And find the terminal velocity find करो बोलेगा. Again if you use that formula wrong हो जाएगा. आपको formula कौन सा use करने का? We have to equate these two and find terminal velocity. Then
So once can we go back? Sir, in that we are not adding the buoyant force, right? How is the viscous force acting up?
viscous, right? Viscous force means what? Friction force. Friction force किस तरह act होगा? Relative motion का opposite direction में act होगा, right? So ये motion fluid में नीचे जा रहा है ना? Viscous because of liquid, because of air, the viscous force will be opposite direction, right? पता है? Of thrust and viscous force in opposite direction and mg के साथ match होगा. Understood? Okay. I'm equated this three. And I brought this to this set, to this set, and equated and solve किया तो we get 2/9 r square g into sigma minus rho by eta. This is formula.
So that it's always, or is it only when net force is 0?
Net force will be 0 always. In the terminal velocity में net force is always 0.
So directly can't we just remember the formula? I mean, like if they gave that all are given in the question.
If they told buoyant force is neglected, what will do? Remember, find the terminal velocity. Then क्या करेगा? आपको ये remove कर देने का, right? This one we have to remove, and we have to equate this two and find terminal velocity. मतलब इसमें sigma rho will be 0 हो जाएगा indirectly, right? If you put rho is 0, then I think you can the terminal velocity directly can get from this. समझ रहे? If buoyant force is not there means rho को value will be 0 indirectly, right? Density of the medium is not there indirectly. We are neglecting that one. So this one remove करके then rho निकाल दिया तो you will get the same value. Okay. So formula क्या होगा? ऐसे लिखने का 2/9 r square g into sigma minus rho by eta. Is the terminal velocity. Sigma is always a density of the solid or any object, a raindrop, कुछ भी होने तो गिर रहा है बोले that one sigma weight is. and rho is the fluid density. इसमें it is falling under the air means air का density you use. Water means water का density you use. Right? तो फॉर्मूला क्या? बोल सकते हो मानो?
Yeah, 2r square g into sigma minus rho by 9 eta or whatever it's called.
2 by 9 ऐसे बैठ करो. 2 by 9 into r square g into sigma minus rho by eta. तो 2 by 9 वाला फेमस है, याद हो जाएगा. Okay? चलो. Now we'll do the first we learn the terminal velocity versus radius and time period का graph draw करेंगे. ये भी sentence पूछा है. Terminal velocity versus tell me radius. So what is the formula? Vt is proportional to r square in the formula. If you see r square n, so that means the graph will be like this. When I talked about terminal velocity versus time, so क्या होगा? Initially the velocity goes on increase करके constant हो जाएगा. After certain time के बाद it is the constant value. That constant value is nothing but terminal velocity. It is constant. This is the terminal velocity versus time, terminal velocity versus r square. ये भी JEE मेंस पे क्वेश्चन पूछा है. Okay? now करेंगे questions.
So let me draw the graph diagram. So which graph diagram should I draw, first one or second one? So for the owner,
What's the difference of O&M?
so one second.
It is proportional to r square. And initially velocity goes on increase करके एक जगह में constant velocity से गिरेगा. That velocity is called terminal velocity.
So one second. Yeah, so done.
फॉर्मूला आ गया ना, और फॉर्मूला इसमें तो सब JEE में स्पेसिफिक करो ना. A water droplet of radius falls in situation where effect of buoyancy is negated. देखो buoyancy force नहीं है बोल के बोला वो. And coefficient of viscosity is given. Density is they told water density इतना ले लो बोल के बोला. Derivation. The terminal velocity of the water droplets. You are asking only Vt is how much. So that formula we can't use, right? So this formula जाएगा. So on sphere में you have to अगर formula भूल गया तो sphere में क्या
We just need to equate the
equal to 6 pi eta r is equal to
Fg 4 by 3 pi r cube sigma g. I mean, yeah, sigma g is equal to 6 pi
eta r
eta rv.
equal to and find terminal velocity and tell the exact answer.
So is that micrometer?
On meters per second. Velocity and velocity is not meters per second.
So
The
the
radius.
Micrometer. 10 power minus 6.
what should I find? Oh, terminal velocity.
Terminal velocity.
So terminal velocity is v.
Vt.
The, no,
Yeah.
in the 6 pi and 6 pi.
So
and r.
water droplet is a what shape?
Vt.
So water droplet is a sphere, right?
Water का
So water droplet is shape of sphere, right?
the voice is breaking. Tell me, let me.
So the shape of water droplet is a sphere, right?
Sphere only, always sphere.
So can't I directly use the 2r square g into sigma minus pi by n 9n?
Use करो whatever you want to answer. JEE mains question करो.
Sir,
क्या answer?
sir, it's option D, but then I'm not getting the 10 power minus 6.
10 power minus 6 क्यों नहीं आएगा?
I'm getting 10 power minus 3.
कौन सा देखो R value tell me 10 power minus
So can you see the options again once?
Sir, R value will be 2 in.
Sir, it's option D only.
blue लेने का ये लोग क्या
Yeah, right. Sir, if you directly use formula, you'll get answer.
Sir, R value, if you square it, then you'll get 1 into 10 to the power minus 12. And 10 power minus 12 will be gone. And then you'll get a decimal.
Okay.
You get
uh,
0.12, you'll get, sir.
Sir, 1 micrometer. Sir, how do I convert 1 micrometer into
Take it.
meter is 10 power minus
Micro is 10 power minus 6.
minus 6. So minus 12. Okay.
Actually क्वेश्चन में उस टाइम में they given the question wrong. ये 10 क्यूब लिया होगा. देखो एक बार ट्राई करो 10 क्यूब.
Sir, 1 minute.
Sir, no, sir, that doesn't make a difference. I think. Oh, 1 second.
Yes, sir, now we're getting 10 power minus 6.
Then we get 10 power 6. If we get 10 power 6 gram minus 3, that's nothing but 10 power 3 kg, no?
And yes. Oh,
Yeah, so
right.
that doesn't make a difference only.
Doesn't make it. Yes, that one. 6 start testing. Gram for
10 power 3, 1.8. Yeah, so look at VT as 1.23 into 10 power minus 4. That's 123 into 10 power minus 6.
Okay. So directly terminal velocity always equals simply 6 pi eta r v is equal to 4 by 3 pi r cube into sigma into g. Okay. If they mention that buoyant force वगैरह neglect किया तो नहीं तो full formula use. 21.
Sir, while for here we're writing 4 by 3 pi r square sigma g. Sigma is rho water, right?
Sigma, yeah. वो जो भी गिर रहा है that is sigma tech always.
Okay, sir. And you have to convert all it to meters.
Yes, always errors.
Why is the calculation so hard?
Normal, the events already there.
Also, we have to find VT by root 2 GH.
इसमें ना
Yeah.
terminal velocity only asking. Terminal velocity attained by the raindrop is.
Oh. Then why did they give height, sir?
Take the derivation. Lot of height is on. मतलब उधर से गिर रहा है बल्कि उसने.
So can I use calculator?
No. Hey, 2021 का. Approximate answer करने से.
So won't they get like negative, I think?
No.
So because sigma is 1.2 and rho is 1000 now.
Sir, after using calculator, I got 4.94.
Again calculator using won't use. That.
So 1 second.
Sir, I'm getting negative.
Yeah, so you will get negative.
Okay, but answer बोलो. Force of buoyancy may be neglected. Buoyancy को neglect किया दिया. Same thing.
So this directly I'm using formula. Wait, into
Density of water we have used, right?
1000 minus 1.2, sir. I want to see if I get this correct answer or not. What is coefficient? 1.8 into 10 power minus. Okay, sir, 1 second. So you do 0.2 into 10 power minus 3 whole square into 10 into 1000 minus 1.2 divided by 1.8 into 10 power minus 5.
So 6 pi eta RV is equal to 4 by 3 pi r cube
Just-
sigma of
Sir,
water.
but if we use that, we won't get terminal velocity, no.
Terminal velocity was 6 pi eta RV. V is nothing but terminal velocity only. 6 pi
Oh my, sir, I thought that V was some other V.
RV. V is nothing but terminal velocity only.
Oh, shit. Sir, too late now.
हाँ,
So you get VT as 4.94.
हाँ, ये आंसर 4.94 is answer. कैलकुलेशन वर्ड से बहुत केयरफुल से रहेगा. डायरेक्ट सी वो लोग क्या भी क्या कर रहे हैं, डायरेक्ट फार्मूला के थ्रू कुछ दे रहे हैं तो दे आर मेकिंग द यूनिट्स चेंज करने का, तो कैलकुलेशन बढ़ा देने का, ऐसे देने का. सो वांटेडली दे वांट टू डू लाइक दिस. A ball of steel attains a terminal velocity this much. They give terminal velocity when it's falling in a tank in the water. Okay, water proportional viscosity they given. Terminal velocity in glycerin. Same thing. If I put in glycerin, would be how much? Asking. In water, में terminal velocity they given this much. अगर same steel ball I put in glycerin में, what will be terminal velocity? Comparison is doing.
Sir, what are the units in the answer?
Centimeters per second.
Okay.
I have a doubt. Sir, how do I convert the Pascal per second into centimeters per second? Oh wait, never mind. No, wait, I should wait. What? Yeah, sir, how do I convert Pascal second into centimeter per second? Like,
Why are you converting Pascal per second to
wait, I don't. Oh, never
So
mind.
we can
never
measure
mind.
as 10 decapoise, right?
10 decapoise, is 10 decapoise. See, Pascal, I told you,
Like 1
is nothing but 10 decapoise, right? So, poise में convert कर लो.
Sir, so over here we have to include buoyancy, right?
इसमें आपको, yeah, but comparison में always take the ratios directly. मतलब full formula only, which is not mentioned, told that neglect करो बोल के नहीं बोला ना. So formula use करके ratio divide करो. Then by this way.
Okay. No, sir, because if I use, if I use the formula, it becomes very big.
Sigma minus rho by eta. Right? Remaining same है. Remaining पूरा cancel हो जाएगा ना. R square वगैरह
But if we use the formula, then we give radius in the question, so we can't use it, right?
See, same steel only it is falling in glycerin, right? So आपको radius का R square will get cancelled. So proportional to check करो. Sigma minus rho by eta इसी पर proportional क्या होगा? If you use the formula also divide किया तो cancel हो जाएगा. 2/9 cancel हो जाएगा. R square will cancel. So now equal करो. VT1 by VT2 is equal to like that. Calculate करो and so. So V2 by V1 is equal to sigma 2 minus rho 2 by sigma 1 minus rho 1 into illustration. So eta 2 by eta 1. So 2 is a glycerin का दाब.
So after using calculator, I got 6.25 into 10 power minus 4.
अभी कैलकुलेटर यूज करो. कैलकुलेटर में पूरा रॉन्ग हो जाएगा. करो. हाथ से करो ना.
Sure. How are you supposed to multiply 6.6 into 8.6 and divide that by 13.2?
6.6. अरे आप तो जरा पेशेंस से करना पड़ेगा.
Yeah, so you'll get 132 into 6.8. So, look at some big calculations. I'm using calculators for 2 minutes.
So I got B.
Document.
Sir, 1 second.
Hmm.
Yeah, so you get option, you get 6.25 into 10 power minus 4.
Yes,
B,
sir.
B.
Should be done. मतलब कैलकुलेट करने के बाद only you're getting, right? हाथ से नहीं आ रहा ना? तो see all G में अभी एग्जाम के लिए मंडे का what is the plan?
So, did you send the 40 years paper for this chapter, like full?
This one, na? This chapter I'll send.
Like this part, yeah.
This part only this part, right? Second part only.
Like from viscosity.
हाँ, yeah, I'll send. देखो आपको इवन फॉर मंडे एग्जाम के लिए सिंपल में नो नीड ऑफ डूइंग ऑल द मटेरियल वगैरह नहीं मत करो. आपको फॉर्मल शीट है ना बाजू में एंड ट्राई टू रीड द फॉर्मल शीट एंड डायरेक्टली अटेम्प्ट द क्वेश्चंस ऑफ पीवीक्यूज. ऑल चैप्टर्स का जो भी है आपको कभी भी टाइम मिले तो भी डेली आराम से वन चैप्टर प्रैक्टिस करते.
So, daily if I do just 2 chapters of PYQ, that's enough, no?
That's enough. That's enough because all models are covered in that. पूरा और क्या चाहिए फॉर्मल शीट मालूम है क्लास में क्या है उसमें भी क्या है पता नहीं. तो ऐसा थोड़ा स्मार्ट वर्क करने का ना. इस एक ही में विल डू मटेरियल, सम पीपल विल डू मटेरियल, सम पीपल डू अदर मटेरियल देन पीवीक्यू बोलते हो वन चैप्टर करेगा एक क्वेश्चन 10 क्वेश्चन आएगा ऐसे इतने क्वेश्चन से कलर्स राइट. सो डन. चलो हो गया. इज आंसर 6.25 minus 4 आएगा. Okay.
So I'm getting 6.6 into 10 power minus 4.
हाँ ओके. मतलब कैलकुलेशन में थोड़ा मतलब क्या होगा 6.25. अच्छा विदाउट कैलकुलेट करो ये क्वेश्चन करो विदाउट कैलकुलेट विल चेक. दिस इज नेग्लेक्टिंग बायोन्सी ड्यू टू एयर.
So, Millikan's all drop experiment was in physics or chemistry?
केमिस्ट्री में इसी में they found the charge of electron is found by this experiment.
Sir, if I wait 1 second. Sir, I would take GS 9.8 or 10.
Not given, but then you can take approximation answer, right? So पहले terminal velocity find करो, then you can use 6 by eta RV. Then you get the answer. Approximate answer check करेंगे, calculation करके कितना कौन करेगा, इधर करेगा तो.
Sir, I'm getting 3.8 into 10 power minus 11.
So I got 3.9 into 10 power minus 9, not 10 power minus 10.
Calculate किया.
Yeah.
हाँ, see, ये जब calculate करा बोले तो calculate use करे तो कैसे है? Terminal velocity find करो first normally by formula. After that you have to use 6 by eta RV because viscous force. कोई भी object is moving under the fluid, there is a viscous force will be formalized 6 by eta RV. वो वाला फॉर्मूला कौन सा विस्कस फोर्स का फॉर्मूला कौन सा है? लेयर टू लेयर वाला विस्कस फोर्स का डिफरेंट है माइनस ईटा ए डीवी बाय डी बाय. दिस इज क्या है? पूरा ऑब्जेक्ट स्फेरिकल ऑब्जेक्ट इज मूविंग अंडर द कंप्लीटली विस्कस लिक्विड में, देन विस्कस फोर्स विल बी एक्टिंग. दैट फॉर्मूला 6 by eta RV. So answer is this one. 3.9 into 10 to the power of minus 10 newtons is answer. Okay. By this topic completely